Right, good morning. For those that don't know me, my name is Martin Bruiser and I'm a performance tester. I've recently moved back into the BAU space after spending a year and a half performance testing on Aurora. Really? What button? The trigger?
The left mouse button.
Okay. So I'm guessing all of you here know exactly what Aurora is. Essentially the delivery of a brand new internet bank nationwide. But since coming back and having a conversation with a few people, I'm not sure that everyone's understanding of what the deliverables are is necessarily correct. So I've kind of bullet pointed these. So it is much more than a new user interface. This has been built from the ground up. This is brand new live architecture, and what's meant by that is essentially failover, dual site, NDC, SDC. And so the event a bomb hits one site, traffic's routed to the second without an interruption to service. There's also a lot of new, more physical tin, and this takes the form of about 80 individual servers, all performing differing roles under various load. And also you've got like new up-to-date end-user functionality, things such as an interactive graphing of balances, new prompt gallery functionality, etc. Now, I think sort of understanding this and the deliverables is key to understanding why performance test was so vital on a project such as Aurora. As well as this, Aurora was actually split into 3 releases, the first 2 of which were focused on current online bank. Those of you that currently use the online bank may notice this at sign-off. You'll see a direct marketing prompt and then an underlying gallery. All of this is delivered sort of bespoke, depending on customer needs. How do I rectify that?
Use it as a mouse, but it's a gyroscopic mouse, so you don't need anything to put the mouse on. Or walk over to the computer.
So the primary objective of performance test on Aurora is essentially to deliver an approach that's capable of measuring and quantifying risk associated with delivering a brand new internet bank, and also to drive this risk down. What you see under these secondary objectives is essentially just a drill down of the above statement. I think what is the key message in all of that really is just to stress the importance of managing these risks as early on in the life cycle as possible. My next slide is going to attempt to give you an example of how we managed to do that in Aurora performance test. I will improve that. So, the project as a whole was very keen to get to give performance an early sight of a pre-prod environment. Obviously, this is brand new architecture. There's a lot of unknown quantities there. So, what we were actually able to do is to provide an early sight sort of a solution to the underlying architecture, was highlight a defect, essentially. So, as I hope you can see from this diagram, Aurora has a load balanced architecture. So, as your end user logs in, 10 web services are triggered at this point and hit a load balancer with this load then distributed to 3 underlying web application servers. The problem being with this method is that the associated response to these calls were actually timing out as a result of them being load distributed. This then was stopping customers from being able to sign onto the online bank, making everybody unhappy. So what, as a performance test team, we were able to do was influence the solution architects into using or introducing what's known as sticky web services, which essentially ties a single login, these 10 web services, to a single application server, meaning that you get a true call and response every time, meaning everyone's able to log in when they want. Obviously, we were able to identify this really early on, saving a huge cost to the program, a huge cost saving to the program, and also, I guess, as performance tests are often sort of seen as a bit of a dark art, and you've kind of got to prove your worth, and we were able to do that right from the get-go. Okay, what does success look like to us? So, we had to prove screen response times were within defined NFRs. So, each and every screen was assigned a rating of simple, medium, complex, or very complex, and each one of these ratings was assigned a performance budget, or a timing budget. We also had to prove 3-year customer projected growth. So in the next slide, I'll give you an example of some of the volumetric associated with the project. But essentially, our 3-year growth can be measured in times current peak hour times by 1.6. Proof system is stable under load for extended periods, so we would prove this by running SOAP tests so as to sort of flush out any memory leaks, bottlenecks, etc. Prove customer throttling mechanism, which don't take this literally. It's essentially a mechanism whereby if we identify a fault somewhere in the architecture, we've got the ability then to limit the amount of people that are able to sign on to the online bank. So, whilst you might have some unhappy people that aren't able to sign on, I mean, this is handled quite gracefully, so you get a message saying, we're suffering difficulties, please come back later. It means the people that are in flight and actually in the application there have, hopefully, they have a good customer experience. Prove audit mechanism reporting under load. This is essentially MI that's going to be used by the business. And prove admin support functions under load. So essentially, as well as delivering a new customer UI or a new bank, essentially, we built a new admin app for our branch staff. And obviously that had to be performance tested.